Hello, this is Stephen Neshiba, and I'm here to help you out with the second part of the Visualizing Thermodynamic Surfaces Computational Guided Inquiry. The second part is right here. It's graph a Boyle isotherm. Pressure is a function of volume for an ideal gas. And we're told that this is the range of volumes that we want to cover. And now at room temperature, we're just going to say maybe that's 300 degrees Kelvin. And so how are we going to do that? Well, we've got a script file that already kind of does a little bit of this for us. So let's go ahead and go back to the web page. There it is, ts2.py. I'm going to right-click on this and download it. And hopefully that will come up here. And sure, I'm going to save it right there as ts2. And now I'm going to go to Canopy and say, well, I want to pick up that file. So here's this open file icon. And there we have TS2. And let's see what it looks like. Let's see. It looks like I had to import some additional resources, but you just copy that in. There's our gas constant. I still have 1 mole. This is a new command. It's called the numpy.linspace, and effectively, really what it does is it says, instead of giving me 1 volume, give me something like 50 volumes, all in the range between 10 and 30. Now, is that what I really wanted here? Oh, no, I wanted between 10 and 40. So I better change that to 40. And there's something that it prints out what the result is. We'll have a look at that. Now, it's just one temperature, 298. Well, we could have gone with 298, but I like 300. There's the ideal gas law and some printing. Now, the other thing about this that's new is there's some graphics here. Figure number 1, this just says that it's going to come up with the first figure number. This clears it out. It's sort of standard boilerplate stuff. This sets up a new graphics window. This is the real key command here. It says plot on the x-axis the volume that we just laid out, and on the y-axis, the second entry there, is the pressure. So we're going to do pressure as a function of volume. These are some sort of prettying up commands. It says give me a label on the x-axis and then give me a label on the y-axis appropriately. And you generally have to have this plot.show command just to sort of tell Python really do flush this out. So I think we're good to go on this. I'm going to run it, and now, hopefully what will happen is it will come up with figure 1, and here we have, there's the volume between 10 and 40, and that's what we wanted, 10 and 40 liters, and it calculated the pressure, and well, it's looking pretty good. Pressures in atmospheres, when we're at about 25 mils, looks like the pressure is 1 atmosphere. That all seems about right. Now, the other thing I want to draw your attention to is here in the command window, there are things that it printed out. Well, this first one is just the run command. That's straightforward, but it said that it made 50 points in the volume, and that resulted from this command, this linspace command, that it made 50 points between 10 and 40, and you can kind of see them there, 10 all the way up to 40. That's fine. Now, when we said pressure is equal to nRT over the volume, since there were 50 points for the volume, it created 50 points for the pressure, and that's what that's reporting out here. There are 50 points in the pressure variable, and there they are. Now, of course, what you really want to do is look at them graphically, which is what was given here. So I think that we have accomplished now the second part of our exercise.